Hello, my name is Tamika Clemens, and I am a biochemistry professor at Western Michigan University Homer Stryker, MD, School of Medicine. And I currently do not conduct any research. I teach medical biochemistry. And so, to give a brief discussion about past research, I've decided to focus on my graduate research, which involved mast cells. And so, mast cells are one of the most important cells as it pertains to your allergic response in the body. So if you think about someone who sneezes, who has a runny nose, what's occurring is there are mediators in the body that are being released that's causing the person to have this outward release of like a runny nose. And so what we did in our lab is we actually examined some molecules, intracellular molecules, so molecules inside the cell called sphingosine 1-phosphate and inositol 1,4,5-trisphosphate to get an idea of the role that both of them will play in calcium release, because ultimately it is calcium that causes the release of mediators such as histamine from the mast cell that can lead to these outward effects such as the sneezing and the runny nose. And so what was already known is that inositol 1,4,5-trisphosphate, or IP3, is responsible for calcium release from the endoplasmic reticulum once it binds to the IP3 receptor that sits on the ER. And it's interesting because when we did some studies with sphingosine 1-phosphate, we also was able to see release of calcium from the endoplasmic reticulum. And so we wanted to know, was this release of calcium from sphingosine 1-phosphate alone or from sphingosine 1-phosphate in combination with IP3? In other words, if we were to block IP3, because sphingosine 1-phosphate caused the release of calcium by itself. Okay, and so we carry these studies out in what we call RBL2H3 cells, or rat basophilic leukemia cells, ultimately hoping that we could do the experiments in human mast cells and get the same effects. So in the RBL2H3 cells, if we would block certain inhibitors, it would actually lead to blocking the calcium release, okay, to a certain effect. So for example, sitting on the mast cell is what we call the Fc epsilon R1 receptor. So these specific receptors that requires the antibody to bind, right, which is the IgE antibody. And that IgE antibody will attach to the receptor and become activated upon the antigen actually binding to the antibody. Okay, and so once the Fc epsilon R1 has been activated because of this cross-linking that has occurred because the antigen bound to the antibody, there's a bunch of downstream signaling molecules that will get activated and ultimately lead to sphingosine 1-phosphate and IP3 going to the endoplasmic reticulum. Okay, so let's back up and talk about the IP3 component, because that is something that has been well studied. And so on the plasma membrane, you have what we call PIP2, or phosphatidylinositol 4,5-bisphosphate. And PIP2 can serve as a substrate for phospholipase C, which is PLC, and can be cleaved. So when I say a substrate, so phospholipase C is an enzyme. We know it's an enzyme because of the ACE ending, ASE ending. Okay, and so that enzyme will have substrates that bind to the active site. And so PIP2 can bind to the active site. It can cleave, and when it gets cleaved, you're going to end up with two different products. One of them is going to be the IP3 that I've already mentioned, and the other one is going to be diacylglycerol. It is the IP3 that has been released that can then go to the endoplasmic reticulum and bind to a receptor called the IP3 receptor. And once that binds, it actually would cause release of calcium. Now, sphingosine 1-phosphate comes into play because we believe that there's a receptor on the endoplasmic reticulum separate from the IP3 receptor that sphingosine 1-phosphate can bind to, and once it binds to that receptor, it enhances the release of calcium from the endoplasmic reticulum. And so we wanted to look at and see, well, what happens if we actually block the IP3, so that now the only thing that the mast cell has to rely on is the sphingosine 1-phosphate. And we actually conducted those studies. We used an inhibitor of IP3 receptor. Okay, and we blocked it, and what we found out is that you indeed need IP3 in order for sphingosine phosphate to do its job. Okay, so IP3 is a critical component for the calcium release. In addition to looking specifically at just IP3, then we went and did the opposite, right, where we just blocked the sphingosine phosphate. And of course, as I've already stated, the IP3 released calcium, but it wasn't to the extent that it would get released if you have both sphingosine phosphate and IP3 together. Okay, which means that you need both of them to get this enhanced effect. What does this mean possibly clinically? Well, if you think about trying to work with the patient and find ways to come up with a new therapeutic that can help relieve a patient's symptoms, it could be possible by inhibiting sphingosine phosphate and decreasing that calcium release from the IP3 receptor and the S1P receptor. You could possibly get it below a threshold in which the patient will no longer have these effects. And so those are the basic studies without getting into too much of the data details, since this is just an intro to get a basic understanding of how to communicate. Again, thank you.